2 lectures ago, we built the int list. It was a really beautiful recursive data structure, very pure, and it allows us to store any amount of information so long as we're willing to keep adding nodes at the end and our computer doesn't run out of memory. So while they're powerful, they have the issue that they're a little awkward to work with. If you want to add to the beginning or the end, you have to do direct pointer manipulation. And so what we showed in the previous lecture was how to add a layer of bureaucracy and produce the SList, where now we have a middleman that we go to manipulate the list. So for example, suppose I want to add to the front of the list. I go to the middleman and I say, hey, please add first. And then maybe what she'll do is, well, whatever magic stuff the SList does. We don't need to care about it as the user of an SList. We simply call the methods of the SList class. So we enumerated a number of improvements, and now that brings us to this moment where we're going to improve the SList yet more. So there's some obvious limitations to the SList, like the version we have right now, you cannot add to the middle, and we could add those features, but there's actually a more fundamental issue that I'd like to tackle, and that is the fact that adding to the back is slow. So if we think about how we add to the end of an SList, inside, under the hood, what our SList does is it iterates through all of the items, and then finally sets the next pointer. Now that is going to be slow because we have to iterate through this list, much like we saw with the size method before. So you might think, inspired by what we did with the size method, about ways that we could improve our SList so that add last is also fast. So ponder that for a moment, maybe pause. Okay, so perhaps you've thought about it and you thought, how do we make size fast? Well, we cached the size. So maybe I could just cache the last pointer. So I would have the size, a sentinel node here, and the last pointer pointing at the last node. So let's think about all the things you might want to do with the list. You want to add to it, get stuff from it, remove it. Now we're going to think big. We're going to ponder, if we have a last pointer, is that enough? Is that enough so that all of these operations will be fast? And if not, which one will be slow? So I'm not going to spoil it in this video, but I'd like you to ponder that on your own.